All right, here we go. Moving on to 6.3. We're going to talk about using similar polygons. Again, this is probably more of a review than anything else. Our vocabulary for this particular section, our key vocabulary, is the similar polygons and scale factor. So let's go ahead and jump right in to make this as short as possible. All right, if you look here, that's the symbol that we use for similar, okay? So whenever you're talking about similar, it has that little wiggly line. It's the same sign as the wiggly line on top of the congruency symbol, okay? But similar figures have congruent angles and proportion sides. So generally what you're going to see is you're going to see a shape that's basically the same shape, but one's bigger than the other. I mean, it's pretty much that simple. But again, just know that similar figures or similar polygons have congruent angles and proportion sides. So here, as we're looking at these two quadrilaterals, we see that ABCD is similar to EFGH. Now, what you need to understand when we do these is that they're still in the same order. And what I mean by them still being in the same order is the fact that A is similar to E. Okay, so angle A and angle E should be congruent. Okay, so when we're looking at our corresponding parts, we should know that angle A should be congruent to angle E. And angle B should be congruent to angle F. Angle C should be congruent to angle G. And angle D should be congruent to angle H. Okay, and again, it goes in the order of the name. So quadrilateral ABCD is similar to quadrilateral EFGH. You still have to keep these in the same order. Now, what goes along with our corresponding parts is our similar statement, or our proportional statements. So like I stated earlier, your angles are all going to be congruent, but your sides are not going to be congruent. Instead, they're going to be proportional. Okay? So side AD is not congruent. So AD is not congruent to EH, but instead, they are proportional. So then what you're going to do is you're going to set up proportional statement of proportionality, and it's going to look something like this. You might have AB over EF is equal to BC over FG, which is equal to CD over GH. Which is equal to dA over HE. This is your statement of proportionality. Okay, and if all of the angles are congruent and all the sides are in the right order, all of these should be equal to one another. These should all be equal. That's what proportionality means. Despite their different lengths, they should be proportional as long as we set it up the right way. Okay? So let's take a look more at depth into that. So here, you have a triangle that has a side of 35, 42, and 28. You have another triangle that has a side of 20, 25, and 30. So let's assume for this particular example that these two triangles are similar. So if I want to put these together, I'm going to put the small ones together. So I'm going to end up with 28 or 20 over 28 or 28 over 20. It doesn't matter depending on how you do it. Okay, but if I start it in this order, the next thing I want to do is I want to put the medium ones together. So then I'm going to end up with, what's my medium one? My medium one's 35 here, and the one in between here is 25. So I'm going to have small over large in this case. I'm going to have 25 over 35. And then I'll put the large ones together. And putting the large ones together is going to give me 30 over 42. Now, if I set these all next to each other and I have 28, 25, and 35, and 30 and 42, if these are truly similar, then the cross products are equal. Okay? So if I take the cross product of 28 and 25, and I end up with 700, and then I take the cross product of 35 and 20, and I end up with 700. These are now similar. This makes these figures similar. And again, that also has to work here. So 25 and 42 multiplied together equals 1050. And 30 and 35 multiplied together equals 1050. And those also have to be equal. And as long as they're equal, they are also proportional. Okay? And so now all these cross multiplies work together. That makes them proportional. So if your cross products equal, then you have similar figures. Okay, and all three of them, I had to make sure that all of these equaled. So here I had 700 and 700, the first set, and then I had 1050 and 1050, that second set. As long as it goes like that in a series and they all equal, then you're going to have similar figures. What you can also do is you could also take these proportions and reduce. Let's say you take 20 over 28. What does that reduce down to? Yeah, if you divide by 4, you end up with 5/7. Okay, what about 25 over 35? What does that reduce down to? You divide by 5, you end up with 5/7. What about if you take 30 over 42? Divide by 6, you end up with 5/7. So all of the cross products, all of the setups, all the sides, similar sides, reduce down to 5/7. And essentially what we did there was we found our scale factor, and our scale factor is 5/7. If they all reduce to the same number, then you're also going to find that they're similar figures. So that's two different ways. You can either, one, find all the cross products, and if they equal, then you have similar figures, or two, you can reduce all the figures, and if they all reduce down to the same, then you're going to have cross products. Then you're going to have similar figures. All right, let's look at another example. In this case, we know that ABCDE is similar to OPQRN. So what we're going to do is we want to find the missing sides. So let's go ahead and set up a proportion. Okay, so let's start with a side that we know. We know AB is 10, and it is similar to OP. Okay, we know this because the order they're in. It is similar to OP, which is 15. I can set that equal to BC, which is Y, over 9. Because I know that BC is similar to PQ. If I want to figure out Y, all I have to do now is cross multiply and divide. I can go ahead and we did that in that last section, so I'm not going to go through all the the steps and setting it up. But we could cross multiply and get 90, and then you end up with 90 divided by 15 equals 6. So you know that this yields y equals 6. If I want to find z, I can do the same thing. Now here's the key. If I'm going to look for z, I'm going to go ahead and use what was already given. So I'm going to stay with that 10 and 15. I could use 6 over 9 now because now this has become 6 over 9. I could use that, but because I created that and I figured that those calculations out, I'm going to go back to what's given. That's always a great test-taking strategy. Just use what's given just in case you screw something up. Okay? So I'm going to go back to 10 over 15 because that's given, AB and OP, and I'm going to find Z. So I'm going to find Z over, what is the corresponding side to DC? Well, if I come over here, I see DC right here, right? So that must mean it is QP. Excuse me. I'm looking at the wrong thing. It's not QP. It's RQ. This should have an N on the end. Here we go. Okay, now, if I set that up, I have 10 over 15 is equal to Z over 12. Go ahead and solve that. Again, I have 10 times 12 is 120. So then I'm going to take that 120 and divide it by 15. And I end up with 8. So this is going to give me a product that is Z is equal to 8. Okay, let's go ahead and continue. Let's find X. Again, I'm just going to stay with 10 over 15 is equal to 18 over X now. I'm going to do 18 excuse me, not 18 over X. It's going to be X over 18. So now I have 18 times 10 is 180. And then you take your 180 and divide it by 15. And you end up with 12. So X is equal to 12. And then finally I need to find W. If I want to find W, I'm still going to use that 10 over 15 because that was given to me. And now I'm going to do 10 over W, okay? Because ED goes with NR. So 10 over 15, you can see right there, that's going to equal 10 over 15. So I don't even have to cross multiply to know that W is equal to 15. Okay, you can. 10 times 15 is 150. 150 divided by 10 is 15. But 10 over 15 has to equal 10 over 15, right? Okay, let me go ahead and erase this. Because now I want to show you something else real quick before we go into the perimeter part. I want to show you something else that you could have done as well. If you start with 10 over 15, it reduces to what? Divide both of them by 5, you get 2 over 3, right? You could have also taken all of these and said, okay, 2/3 is equal to 10 over 15 is equal to y over 9. You could have done it that way and ended up with y is equal to 6. And the reason you could have done that, what was the benefit of doing that? Well, the benefit of doing that would be using smaller numbers, because now I know that 2 times 9 is 18. 18 divided by 3 is 6. That's kind of easier mental math. You could have done that as well. And then if you would have noticed that when you replace this y here, you would have had 6 over 9. And 6 over 9, if you reduce that by 3, you get 2/3. So every one of these fractions, when I set this up, 10 over 15 should be 2/3. 6 over 9, 10 over 15 should be 2/3. 6 over 9 should be 2/3. Okay, we figured out z earlier, and z was 8 over 12. That should be 2/3. And then we figured out W over 10, and we said that W was 15 over, and 10 over 15 was 2/3. And then X over 18 should have been 2/3. And we said X was 12 over 18, so that is 2/3. And you could have flipped it around. You could have done 3/2 depending on which figure you started with. Okay? So there are a couple different routes to do this. You can either use the fraction, and you can either use the reduced, or you can go ahead and you can cross multiply and find it that way, which most of you will do that only because you've been doing it since 7th, 8th grade. Okay? All right, so if you go back to our original question, it also asks us to find the perimeter of each figure. Okay? Well, let's just start by finding what we already figured out. We knew that Z was 8, and we know that Y was 6, and we know that Z was 8. I'm sorry, X was 12, not 8. X was 12. And W is 15. Now, since we've already done all the legwork and figured out all the sides, what we can do is we can just simply add up all the sides to calculate the perimeter. So the perimeter of A, B, C, D, E is equal to 10 plus 6, which is 16, plus 8, which is 24, plus 10, which is 34, plus 12, which is 46. On the other side of that, we know the perimeter of O, P, Q, R, N is equal to 18 plus 5, which is 33, plus 9, which is 42, plus 12, which is 54, plus 15, which is 69. So we figure out the perimeter of the larger one is 69. Now, watch what happens when I take 46 and I put it over 69. If I reduce that, what do I get? That's right, it's 2/3. So, if I wanted to figure out the perimeter of the larger one and I only knew the small one, what I could have done is I could have said, okay, 46 over what is equal to 2/3? And there I could have cross multiplied, and I would have had 3 times 46. Got 138, and 138 divided by 2 is 69. So I would have been able to figure that out using our cross multiply and divide as well. Either way is fine. Okay, you just have to figure out, depending on the problem, which scenario will be quickest and easiest for you to use. Okay? Hopefully this is simple so far. Again, as always, if you have any questions, please feel free to send me an email. Make sure you write them down, come to tutoring, whatever the case may be. Okay? All right, let's look at this next example. Based on what we just learned, we have two triangles that are similar now. One has a side of 10. One has a side of 4. And now we have a perimeter of 40. So the first thing I want to figure out is I want to figure out that scale factor. Okay, I want to figure out that scale factor. And just as a refresher for those of you who have forgotten, the scale factor, as for a definition, is the ratio of corresponding sides. Now, when we talk about the word ratio, we're really talking about division. So scale factor is a ratio of corresponding sides. What we just figured out is that the scale factor of sides is also equal to the scale factor of perimeters. Which makes sense, right? Because we're taking those corresponding sides, we're taking all of our sides, adding them together, taking all the sides, the other one, adding together. All we're doing is addition. Addition doesn't change a whole lot. So that it's logical that the scale factor of sides, corresponding sides, would be equal to the scale factor of the perimeters of the two similar figures. So with that being said, let's go ahead and figure out the perimeter of this smaller figure. So the first thing I want to do is I want to find this. Well, I could take 10 over 4. If I reduce that to make it a little bit easier, I divide both of them by 2 and I get 5 halves. So my scale factor is 5 halves. Now, whenever you're writing a scale factor as an answer, your scale factor will always be in reduced form. Okay? So my scale factor is 5 halves. So now I could take that 5 halves and say, okay, 5 halves is equal to 40 over x to figure out the perimeter of the other figure. So then I end up with 40 times 2 is 80. 80 divided by 5, and I end up with x is equal to 16. Now, for those of you, hopefully you have this already, I'm going to go ahead and erase this part down here. I want to show you one more thing. For those of you who are wondering, because I know that, there's a lot of you guys out there that always ask that question of, well, can I do it a different way? Can I do it a different way? What if I did 4 over 10? Will that make a difference? Yeah, you can do 4 over 10 if you want. So let's see what that looks like. What if I started with 4 over 10? So, okay, my scale factor is 4 over 10, which still reduces down to, in this case, it doesn't reduce down to 5 halves, it reduces down to 2/5. If you use it this way, then what you're going to have to do is use 2/5 is equal to, which side did I start with? Which one goes on top? Yeah, the small side goes on top. So now I need x over 40. In any case, you still end up with 40 times 2 is 80. 80 divided by 5, and x is still equal to 16. It doesn't matter if you figure out the scale factor of 5 halves or 2/5, and depending on the question. Now, if the question says, what's the scale factor used to make the smaller figure, then you would use 5 halves because you're going from large to small, or vice versa. So you kind of have to look at the wording of the question, but if you're just solving for an unknown side or an unknown perimeter, you can go either way you want as long as they're in the correct order. Bigs on top, then the smalls are on the bottom, okay? Or smalls are on top, then both bigs are on bottom. As long as they stay together, you don't want to interchange them, okay? Hopefully that made sense to you. All right, last but not least, if the sides are similar, then special segments are also similar. Okay, so that means stuff like altitudes, medians, angle bisectors, etc. So if the sides are similar, if the shapes are similar, or the sides are similar, then those special segments are similar as well. So look here. On this particular one, we're assuming that these shapes are similar. Okay, so that means we could say that 48, and we could fill in other parts. This is 48 and 48 because those sides are congruent, and this is 40 and 40. So we could say that 48 is similar to 40. If that's the case, what is the x value? Well, we can figure that out because we know the other similar side, which is 35. What does this represent? What does this particular thing represent? Yeah, it's a median, right? Because it is from a vertex of an angle to the opposite side, and it creates a midpoint, right? So that's a median. Okay, that's a median. It's not an altitude for those who think it's altitude because it doesn't have a right angle symbol. Altitudes create a right angle, right? All right, so since the medians, we have the median of the smaller figure, we can figure out x now. Okay, so all I would have to do is do 48 times 35, and 48 times 35. And again, I'm going to go ahead and show you the algebra since we haven't done it, just to kind of a review. So I'd have 48 times 35 is equal to 40x. 48 times 35 is 1680, which is equal to 40x. Divide both sides by 40, and I end up with x is equal to 42. So the median of that larger figure would be 42. And hopefully you got all that. Like I said, pretty self-explanatory, pretty simple. If you have any questions, just let me know. Have a great day.